So in this video, we're going to talk about evaluating functions. We'll evaluate functions at a specified input value. We'll evaluate a function at a specified expression, and then eventually I do want to evaluate a difference quotient for a particular function. So let's get into it. All right, so let's go ahead and begin. Let's go ahead and create a function. All right, so let's say let f of x equal, we'll start pretty basic for now, and then we'll create a different function and use what we learned with this basic function and build upon the idea of evaluating functions. So let's let f of x equal, let's say x squared plus 3. Let's find f of 2. So what this notation means is if I have a function f of x is simply the name of this function. So I have a function, it's a function of x. The x indicates the input. So if I want to find f of 2, then I'm simply just going to take this value of 2 and plug it into every single x I see in my function. So if I plug that in for x here, I'll have 2 squared plus 3. And then we evaluate using our PEMDAS, our order of operations. Please excuse my dear Aunt Sally. And so here we will take that 2. It's squared, so we'll make sure we do that first. So 2 squared is 4. And then we would add 3. So now we have 4 plus 3, which is 7. So f of 2 is equal to 7. All right. So if you think about what that actually means, on the graph of this function, f of x is equal to x squared plus 3. When your x value is 2, your y value is 7. And so that actually corresponds to a coordinate on this graph. That coordinate would be 2, 7. All right. Now let's say I wanted to find f of x plus 3. All right, if I want to find f of x plus 3, then let's pull this back up and let's think about what this means to do. Well, just like before, what I wanted to do when I evaluated f of 2, I took the 2 value and I plugged it in to my x values in my function. Now, in this function that we only have one x value. But if we had a function with multiple x values, we'd have to make sure we plug it into every single x in that function. And the next function that we look at will be sure to have at least 2 x values. And so for this, what you need to do here is take the expression x plus 3 and plug that in for x. So if I just circle it and I say, okay, instead of 2 like we just did before, I'm going to plug in the expression x plus 3 into my x. Now you might be thinking, okay, well, why am I plugging in something involving an x into an x? Well, we can kind of see what this means graphically in just a second, or at least discuss it. So when I plug in the expression x plus 3 into my x value, I'll have in parentheses, notice anytime I plug something into my x value or into my input, I put parentheses around it. So before I put 2 in parentheses, and this time I want to put x plus 3 in parentheses. So I have x plus 3 squared plus 3. Right? So let's pull the screen back down and let's work this out. All right, so now we have to jump into our algebra bag a little bit, and we have to say, okay, well, I have a binomial squared. So when you have a binomial squared, what you would like to do is write it out twice. X plus 3 squared is the same thing as x plus 3 times x plus 3. And then you have that plus 3 on the outside, right? So all I did there was, instead of writing it as x plus 3 squared, I wrote it as x plus 3 times itself. Okay, and I wanted to do that so that I can express to you that when you multiply binomials together, two binomials at a time, there's a method known as FOIL that you have to use. And so FOIL means you're going to multiply the first times the first. So x times x. When we do that, we get x squared. And then we're going to multiply the outer. The O means outer, so the two outer terms. X times 3. So x times 3 is 3x. And then the I in FOIL is the inner. So we want to take the two inner terms, 3 times x, multiply those together and get plus 3x. And then finally, the L represents last. So we want to multiply the last two terms together. So essentially what you want to do is make sure you multiply every single number in the first binomial or term in the first binomial times every single term in the second. And so 3 times 3 is 9. So that is x plus 3 squared FOILed out. Now, of course, I have common terms that I need to combine, but don't forget that this plus 3 is still there, so we have to bring that down. And now at this point, I just want to combine my like terms, anything that's common. So if you notice, there's no other x squared term in my expression here. That's the only one, and therefore there's nothing to combine that with, so it's just x squared. But now if we take a closer look at the x's, there's a 3x and a 3x here, right? And so those 3x's are common terms. We can combine them together. 3x plus 3x is equal to 6x. And then lastly, we have our constants, plus 9 plus 3. So when you add those together, they are common terms. They're both constants. Neither one of them have a variable. So add those together. 9 plus 3 is equal to 12. So that is what f of x plus 3 equals. All right, so let's look at another function. So let's first find f of negative, let's say negative 3. F of negative 3. Okay? So f of negative 3, just like before, what we're going to do is we're going to take negative 3. That notation right there is telling me that I want to take negative 3 and plug it into all my x's in my function. So there's an x here, and there's an x there. So I want to make sure I plug in negative 3 into both of those x's. When you do that, you'll have 4 plus 2. In parentheses, we're going to plug in negative 3 for that x. And then in parentheses again, we're going to plug in negative 3 for that x as well. All right, so if we actually evaluate here, we have 4 plus, all right, 2 times negative 3 is negative 6. I'll put it in parentheses. And then here we do have to be careful. With our order of operations, exponents must be, we must evaluate our exponents first. And so negative 3 squared is positive 9. Do not say that these two negatives make a positive. Don't do that. You cannot multiply those two negatives yet. You have to square negative 3 first. And so negative 3 squared is 9. And so I have minus 9. So you do have to be very careful. So now there's no other multiplication going on. When you add a negative number, you're essentially subtracting. When you subtract a positive number, you're subtracting. Now we're going to go left to right. And we're going to have 4 minus 6 is negative 2. Minus 9 is negative 11. So if you were to graph this function in your calculator, I guarantee you there will be a coordinate negative 3, negative 11 on this graph. Right? All right, so now let's find the difference quotient of this same function. The difference quotient formula is f of x plus h minus f of x all over h. Okay? And so remember earlier in the video, we evaluated a function at an expression. So we do have to make sure we are very, very careful here, because this is telling me to take the function f of x and evaluate it at the expression x plus h. So let's remember what that means to do. That means to take x plus h, and everywhere I see an x in my function, I'm going to substitute in x plus h. So let's see what that looks like. We'll have 4 plus 2 x plus h minus x plus h squared. So everywhere I saw an x in my function, I plugged in x plus h. Okay? And I'll make sure I'm color coding this. So there's the first part. And now the next part is to subtract f of x. Now I do have to be careful here, because f of x is a quantity. And so we want to take f of x and keep it together. So in other words, put parentheses around f of x. So I have minus f of x in parentheses. So you have minus, in parentheses, what is f of x? Well, it's 4 plus 2x minus x squared. Slide my screen over just a tad. There we go. And all that is over h. All right. Make sure we calculate everything correctly. So make sure you follow your order of operations. So the first thing I want to do is take that x plus h that's squared, and let's FOIL that out, okay? Now, when I square x plus h, that entire quantity will be subtracted. So I want to make sure I put x plus h, what that product is, x plus h squared, what that product is, I want to keep that in parentheses. That would simply be x squared plus 2xh plus h squared. And so, like I said, we'll just continue to write everything else exactly. Just like that. Continuing to follow your order of operations, what we'd like to do now is distribute the 2 into this binomial. And let's go ahead and do all the distributing in the same step, because I know I'm simply going to distribute that 2 into this binomial. There's a -1 sitting out here. I want to distribute that into this trinomial. And then I want to distribute this -1 into this trinomial. Okay, and so what I'd have is 4 plus 2x plus 2h minus -1 times x squared is minus x squared. -1 times 2xh is minus 2xh. And then finally minus h squared. And then when I distribute the blue -1 into my function, so the minus f of x part, I never color coded that earlier, so that's that part. When I distribute that, basically that's just going to say minus 4 minus 2x plus x, plus x squared. All right, from here, what we'd like to do is if we see anything in common in the numerator, we want to try to reduce it. So let's see here. We have, let's use yellow. All right, what we notice is a positive 4, -4. They will reduce down to 0. I notice a 2x and a -2x. Reduces down to 0. And then finally, I see -x squared positive x squared, which you got it, reduces down to 0. And so what do I have left in my numerator? I'll have 2h minus 2xh minus h squared, and I'll just keep it all in red at this point, all over h. Okay, let's scoot the screen to the side. Okay, so we're almost done. Now what we want to do is, notice in the numerator, there's 3 terms. Each of those 3 terms share an h. So these 3 terms have one h in common. So what I want to do is factor out that h. And what I'd have left is, and so 2h divided by h is 2, and then minus 2x, and then minus h. All that, of course, is over h. The reason we wanted to factor out that h is because now we have an h in our numerator and an h in our denominator. We all know when you have the same value or factor in the numerator and denominator of a fraction, they reduce down to 1. And so what we'd have finally is our result, which will be our difference quotient, and that will be 2 minus 2x minus h. And that's the difference quotient. All right, so I hope this video helped. I'm immediately going to record a second video where we find the difference quotient of a radical function. So please, if you need help with that, tune in to that video. I hope this video helped. Leave me questions or concerns or comments in the comment section, and stay tuned.